So I have studied how the sand motor influences the macroinvertebrate community, both on the wet and the dry beach. And macroinvertebrates are animals that include worms or crustaceans or insects. And I look at food availability in particular, so how this community is affected by food that is available on the sand motor. So at the lagoon we found different species than you would find normally along the Dutch coast. And we found species that are more common at mudflats, and it's a very different environment where there's less effect of waves and wind, it's more shelter, there's more food. And this attracts different kinds of species. So that's so the sand motor, by having this shape, actually creates a higher biodiversity.
I'm mainly focusing on the importance of the coastal zone as a nursery area for juvenile flatfish. From the experiments that we've conducted, we can see the importance of habitat and the grain size for juvenile sole. So an advice would be to carefully consider what the grain size of future nourishments will be in order to maintain suitable nursery areas along the coast for juvenile flatfish and their recruitment to adult populations in the future.
I work on macrozoobentic biogeomorphology in the coastal sea. I'm fascinated by all the small little creatures that live on the bottom of the sea. We observe that at regular nourishment sites there can be a negative effect on the biodiversity, and it can take up to 10 years for recovery to take place if the grain size increases. Whereas in contrast at the sand motor, we find that the overall biodiversity increases after the construction. And we think that has to do with the environmental heterogeneity that is created by the shape and the size of the sand motor. Nourishment design matters. If we want to maintain a healthy ecosystem, clear water for recreation and natural aesthetics, and maybe even enhance coastal flood defenses, then we have to design a sustainable coastline.